Now that we understand a little bit about cache coherency, let me show you a different approach. This approach probably isn't the most elegant approach or flexible approach, but I want to focus mostly our attention on getting this design going before we go and do some major cache coherency overhauls. So I think the simplest thing for our components is to come into my game right here, and when we say ship, right below that I'm going to say entities, renderer component ship renderer. Alright, so when an instance of my game is created, the ship data will be right here, and immediately after, because C++ is bound to laying out the data sequentially, the renderer ship component ship renderer will be right here. Something else to consider is the packing of this, but I don't want to get into packing and alignment right now. We need renderer component though, so pound include entities components renderer component. Now we have ship renderer. Hopefully you can see though, using this approach we're going to throw in several components. All of a sudden we'll, if we have lots of these bottle caps, this will get kind of hideous and bloat our game objects. So maybe we'll come back, revisit this, and make a separate class that's whose responsibility is to manage this. I mean, another thing we could do is just make a ship class and then have the ship entity inside of that class and the ship render. That would be a simple fix to this. Anyway, I'm probably beating a dead horse. Ship add component, new renderer component. Instead of saying new renderer component, I want to say ship renderer. But this function takes a pointer to a component, so I have to take the address of ship renderer. Let's go back to the renderer component, and it's pretty empty, right? But I said, let me make a new vertical tab group. I said in a previous video that this render component essentially has to keep track of this ship renderable and set its where matrix to the position of the ship, or position of our entity. So somehow I need to get this ship renderable to the ship renderer. And just with a little bit of foresight, I'm going to make a void set data function here. I could do an initialize, and initialize would take a renderable pointer like so, but it's actually going to turn out we want to do the initialization scheme with this component system. We want to do it differently, where all initialize functions take 0 arguments. I'll get to that later. So another convention would be, well, let's make a constructor. Okay, well, if I drop a constructor in here, then all of a sudden I've lost the ability to just throw ship renderer here. The compiler wants to invoke the constructor at this point, right after the ship constructor. It's all part of my game, so the constructor won't add the flexibility I'm trying to gain here. So my next best thing is to have a convention where all components, if they need data, then we will call the set data function. And the set data function is where we will pass the data that the renderer component will use. And then later on we will make an initialize, or I guess bool initialize function that will ensure the data has been set and that sort of thing. But we're getting there. For now, let's just have a set data renderable. And we actually need one of these in here, like so. And then, of course, since we're storing a pointer, we have to do our same trick we always do, namespace. I think we said it was rendering. And then we said class renderable, like so. And since it is a namespace, I have to say rendering, : Control C, Control V. Let me scroll out a little bit so we can see it. Set data. And I'm tempted to make this inline because it's going to be a very simple function. But one thing about inline functions generally is, I mean, yeah, I could inline this because it's going to do one thing. It's going to do one simple thing, and inline would be fine. But then I have to put the inline function either right here directly in the class declaration, which kind of kludges up or blunders up my header information, or I could put it down here at the bottom of the header file, maybe a little bit more clean, but then that's a headache. And we've seen using INL files, and I could do a include an inline file here so that at least the code is in another file at the bare minimum. But I like to be a little bit more intelligent with my inlines and not inline just to inline. I like to inline functions that will be invoked several times. What does inlining buy us? Inlining buys us speed and execution as far as not having to create an activation instance or another stack frame on the call stack. Okay, every time you call a function, that puts another stack frame on the stack, and a bunch of things associated with that I don't really want to get into in this video. This function is going to be called once and probably never ever again. So I'm not going to be as diligent about inlining this. Maybe I'm wrong, maybe I'm right, who knows. Let's go to the CPP file and put it in here. Scroll out, we need the entities namespace, and like so, rendering component, and that should be good. KF, control enter. This renderable gets renderable. And that's it. So you may think, Jamie, inline that. Nope, not going to. At least not now. Okay, so we need to call that set data over here. We'll do this ship renderer dot set data ship renderable, like so, and then we add the ship renderer to the ship. So then the next question to ask is, how is the renderer component supposed to know when to update the renderable? Well, one fundamental piece of this component design pattern is an update function. So I'm going to save all the files and close everything out except our renderer component CPP and header file. Let's go to component here, and we have a virtual void update with a lowercase e, and I'll actually just give it an empty body right here because it's virtual. It's update. Component doesn't really have anything to update. It's the derived classes that will override this if necessary. They don't necessarily have to, but generally all components will. And then let's go to RendererComponent, put this right here, but we don't have to declare it virtual because the base class declares it as virtual. And I'm not going to implement it here. I'm going to actually move it down below setData, because setData theoretically should be called before update. That's just my kind of mental way of keeping track of stuff. I'm going to put an update inside of the renderer component, like so. And let's zoom in here a little bit. Okay, it's real easy. I need to take the entity's position. Right, here's the entity. Remember, we put this very special member right here, position, inside of entity. I need to take the entity's position to which this renderer component belongs to and update the position matrix, the where matrix on the renderable. Let me do a little bit of drawing here. We have an entity instance. Okay, I'll call this ship instance. That's how you spell instance. CE on the end. Anyway, ship instance. It has position. Okay, position. And we also have a renderer bottle cap or component piece right here, renderer, that we add to the array of the ship instance. And all renderer has to do is say, hey, what's your position? Let me update the renderable's transformation matrix based off that position. The only problem is, how do you see anyway how this renderer component can access its containing entity? Right, this black box, this ship instance, is the containing entity. Do you see any way we can access that? Well, no. We need to set that up because all components will frequently need to access their containing entity and interact with other components inside of that entity. So that's the framework we're going to set up in the next video.